we'll be asked to find the obtuse angle, Trigo ratio of obtuse angle. Hello. Okay, listen. Because this part, hello. Okay, this part in real life don't have one. It's an abstract idea, so I want to talk a bit about obtuse angle. When we use Trigo ratio, we always have a right angle triangle. But in a right angle triangle, what is the biggest angle? 90 degrees is the largest angle already. Otherwise, you won't have any right angle triangle already. If you draw bigger and bigger, even this angle becomes bigger. This is 90. You can't go bigger. But mathematicians, they don't want to stop with a right angle triangle. The Trigo ratio only about acute angle. All these are acute angle. So mathematicians, they want to find the Trigo of an obtuse angle. Okay? But obtuse angle, by right you cannot form a right angle triangle. That's why the idea need you to use a bit of imagination. So let us start with a normal right angle triangle. Let's say this is 30 degrees. My sine of this 30 degrees by right is this opposite divided by the hypotenuse. So this opposite, when I look at a coordinate geometry, it is actually my y value. Okay? Then we don't want to stop at 90 degrees for acute angle. The mathematicians want to go even bigger angle. So imagine if I have this side is 30, then this side will be 150 degrees. So this 150 degrees, if it forms a right angle triangle here, it will have the same y. And on coordinate geometry, your y going upward is positive. My h is still the same. Okay? So that is why they say that in trigonometry, the sine of 150 is the same as sine of 30. Because the opposite is your y. Your y is positive. Okay? Then this will apply for all angles. If my angle is a bit smaller, let's say 10 degrees, then here will be 10 degrees, I will get the same y. Then this angle will now be 180 minus 10, so 170. So sine of 170, wow, my handwriting cannot. The sine of 170 will also be equal to the sine of 10 degrees. So these two angles, no matter how I change, what is the relationship? 180. They will add up to 180. Okay? So in your textbook, you will see sine x equals to sine 180 minus x. Actually, this is what it means. The sine of the obtuse angle will be the same as the sine of the supplementary angle. So if you remember by this, it is easier than remembering your formula in your textbook. The obtuse angle is always the same as the sine. Okay? So this is the first part. But there is a second part.
Guys, you all don't believe right. You all press the calculator and try to add up. You use the calculator to try to solve the pair of supplementary angles.
Actually, bro, what the hell, bro?
Okay, sine 10, sine 170, sine 60, sine 120, sine 30, sine 50. It's the same ratio. Okay?
Actually, bro, what the heck? Clean the fighting. No, they must add another 100.
Okay. One more. Jaden. Hey, pay attention. One more.
Fine.
So that one is for sine. What about cosine? Cosine is adjacent over hypotenuse. Okay? So same. If I have an obtuse angle, it is still my adjacent over hypotenuse. But this time, my adjacent is not my height, it is not my y, it is my x. So this x coming to the right hand side is a positive value. But for the same value, this x is going towards the left. So this is actually a negative value. The value is the same, but one is positive, one is negative. That's why cosine of 150 is in value the same, but one is positive, one will be negative. It goes the same for all any other angle. The cosine number is the same, but the sign is different. One is positive, one is negative. Okay? So for sine, obtuse and acute is the same. But cosine, obtuse and acute is different by the positive and negative. Okay? So this is the reason why. Next.
Is there heads?
Okay, so in your textbook, you will see these two equations. But how you understand, how you remember, I think you go by remembering number is easier than remembering your x. Okay? Obtuse angle, the sign is the same. Cosine, the sign is different, like that only. But the values is the same. Okay? So with that, you can try your questions during tomorrow HPL.